Good morning and welcome. Thank you for participating in this module. Well, we think that this module, without this module, and we are going to start speaking about the control of the vinification or the wine-making process. In 1,500 years, there's been no advance or no development in the processes for winemaking, and the first tanks appeared in more or less around 1980. And in 1996, the Studio Archimede Enologia, where 5,000 is taking the acronym, carried out the first computerized temperature control. And so, since 1999, this is the only bus control system working with a multi-microprocessor. It is a platform that is really process-oriented for enology. Technology and innovation are useful if they improve quality and the quantity of a product, the process efficiency and punctuality, and the production costs. Some important innovations introduced in enology, thanks to this SAEN 5000 Parsec platform, is the centralized bus system with just one cable, one wire, vertical and horizontal possibility to be expanded, centralized control of all installations and facilities in the cellar, in the winery, and intrinsic security through or thanks to the multiprocessor technology. All these technologies can be introduced as a 4-point industry applied to enology. Some other innovations, technological innovations introduced in enology from the Parsec technology are the enological temperature control, the multi-sensor and stratification control, also installations that are distributed for very accurate micro-oxygenation, the dynamic integrated traceability, ADCF, which is dynamic control of fermentative kinetics, interactive automation of winemaking, Afromat, and the word maceration comes from Latin, as you know, and it is the action and the effect of keeping some solid submerged in liquid at ambient temperature with the idea, with the purpose of softening it and extracting the soluble part from it. The compacted marks that are not disgregated and they are appropriately wetted entail a very difficult dissolution caused by an excessive concentration of the substances that have been extracted. So there are different types of macerations, the ones that you see here, and in all functions that are handled and controlled by SAEN 5000, of all these functions, we are talking only about the parts related to selective macerations. And we divide into two categories these techniques and equipments: fermentation in an open tank, mixing in modulated selective extraction, and the fermentation in a closed tank, talking about the nectar winemaking machine and the ADCF. So this type of fermentation in closed tank is a fermentation that takes place in conditions of saturation of CO2 using the gas produced by the fermentation without using any mechanical tools. Maceration in overpressure of CO2 is included in the next module, and the Dr. Bartolini is going to speak about this in the next part of the module. So, nectar is a technique that uses vinification or winemaking in saturation of CO2 using the gas produced by fermentation, and it is an important tool and the synthesis of the best technological practices. Using the energy produced by fermentation, it makes an automatic partial deletion without using pumps, and the maceration in delestage, automatic partial delestage without using pumps, and maceration in overpressure of CO2. This is the nectar effect, and with soaking isobarically and disgregating this hut, maximizing the result. And then we will speak about the fermentation in an open tank, where the most revolutionary technique is air mixing in a modular injection, which is a single, unique solution that is patented by Parsec. We will see also the technique of the bazuqueo, which could be translated as shredding with gas, which consists of injecting gas or compressed air under the hut, with the idea of disgregating it. For decades it has been used manually with more or less domestic methods or different solutions present in the market. Only in the year 2000, or from the year 2000, more automated solutions were proposed, by example in the 2001 pulse air system by using bubbles, and the various automatized techniques proposed were never spread because they needed very voluminous injectors. They did not break that hut totally. We had to combine them with the common techniques, the lestage, and only, well, they were using very important amounts of gas, and they were dragging alcohol. And it is easy to verify that up to 2015, no winery in the world had eliminated sprinklers or pumps or delestage or special fermenters or funnels, etc., to replace them with the different solutions that are present in the market. In practice, all the techniques with compressed air bubbles, like nitrogen, air, CO2, that may be efficient for other sectors to mix fluids, but for making red wine, where there is a semi-solid hut that is over a fermenting liquid, well, they were not considered valid. Let's see what is the change respect to the past. This is a graph that sums up the tanks with compressed air treading or high gauge tanks. And from 2015 with modulated injection, we see that the amount of tanks that are there working constantly for more than 12 years and constantly kept in around zero have been exponentially growing in the last 4 years. These are images of installations that were done in different tanks of different sizes, different volume, and different dimensions and shapes in the whole world. What has changed really in the technique? The injectors are extractable and they are installed at the sides of the tanks. They are oriented according to the geometry of the tank. Each injector is equipped with a valve. And all these actions are synergic and they are intermittently injecting air, and there are different times of work and break that can be changed based to the desired result. The last two consequences are included, and they are giving the name of modulated injection to the whole system. And here you can see a part of the European patent where this shape of the injectors is explained, as well as the modulation process, etc. And the new process that has been patented by Parsec, the air mixing modulated injection, MI, is a technique that through modifiable injections, unmodulated injections of air, for example, are making or forming disgregating waves that submerge and disgregate the liquid hat without any disruption in the movement. The injection of air under the hat is an old technique that yesterday was practically not used, but today, thanks to the modulating injection air mixing system, now we are changing the manufacturing process of tanks in all the enological sectors. We have carried out almost 1,500 installations from 2014 up to now in the whole world. This technique has been prized as an innovation or awarded as an innovation in different important manifestations on a world level. Let's see the characteristics of the air mixing modulated injection system. We will start from the feature of affordability of the system, which decreases the total consumption of gas or compressed air. Thanks to a centralized management of the whole lot of tanks, we can improve the whole performance of the system. It is applicable practically to any type of existing or new tank. It is a single platform for all controls: temperature control, micro oscillation, air mixing, density control, fermentation, kinetics, levels, etc. It also involves a very important energy saving in frigories, thanks to a better development of fermentation, and there is a homogenization of the hats and the lesser stratification of temperature respect to traditional winemaking. In electricity, because we save pumps and other equipment. Let's see the optimization of the enological process. We have an extraction according to the fermentation development, and we can vary this extraction based on the fermentation synergies. The removal of the problems caused by thermal stratification, the prevention of the appearance of sulfur compounds, and the better extraction of better extraction with softer tannins and fruit aromas. So the full disgregation of the whole system, of the whole hat. There are no parts, I mean the whole hat is just detached, and there is a facilitated removal from the barrel. We have extrapolated the Science 5000 system here. We're talking here about Pinot Noir in the 2017 harvest in California with a tank with 77,000 liters. And we see the two temperature sensors, the one on the bottom and the one on the upper part. And thanks to the air mixing that are proportionals in the part of the tumultuous fermentation that are more intense, and they are making the bricks to go down, they appear here in a softer way, and you can see how temperature of the two sensors is homogeneous, which represents homogeneity of the whole mass and no stratification of temperature. And this other graph that is really recent, we have taken this graph from the last harvest in Argentina, and here we speak about Malbecs. These are tanks with the Science 5000 tank system, and this is micro and micro oxygenation, and on the right hand side we have tanks with the traditional method. We're talking about 50,000 liter tanks, and as a traditional method there were 4 or 8 with boundum and 1 telestage per day, so one picking up and 1 telestage. And in Argentina there are macerations that are really long, with 2-3 weeks time, and this graph is really important because it allows us to understand that we get optical color intensity that is very significant 1 week before respect as per compared to the traditional method. We are talking about very large, long winemaking processes, like 14 days or more. So you see here on the graph on the right-hand side in orange color, you see that by increasing the number of days macerating or fermenting, the optical intensity increases. In the air mixing system, we see that the optical intensity gets to an important value after 2 weeks, and afterwards, following the fermentation, we don't have any interesting increase. We have a constant value, more or less constant value. In Malbec, we have an average of the optical intensity with the air mixing system of plus 16%. 16.3% respect to traditional maceration. Here we have analysis of 3 tanks with Cabernet Franc variety, where we see that even though the tanks are not representative as in the case of Malbec that we saw in the previous slide, we see that the average of optical intensity is even higher, and we are going to achieve a plus 25% of color. Practically, these data are giving us a lot of confidence in order to continue investing and improving this new technique. Practically, I'm going to say that very soon will you be able to find in bookshops the new translated edition of the book called Oxygen and Wine, translated into Spanish. and with the new scientific contributions of Professors María del Álamo Sanza and Ignacio Nevares, and we thank them very much for this important work. Thank you very much for your attention.